Once the cell constant is determined, this conductivity cell can be used to measure the resistance or the conductivity of any electrolyte solution. This is the setup of the Wheatstone bridge. R1 is the variable resistance, P is the detector, R3 and R4 are the resistance of any metallic conductor. R2 is the conductivity cell containing the electrolyte solution whose resistance has to be determined. Now, when the Wheatstone bridge is balanced, no current flows through the detector, and at that instant R2 into R3 is equal to R1 into R4. R2 is the resistance of the solution present in the conductivity cell. So R2 is equal to R1 into R4 divided by R. Once the resistance of the solution in the conductivity cell is determined, the conductivity of the solution can be obtained by making use of this relation, that is, conductivity is equal to cell constant divided by the resistance of the electrolytic solution. Here the resistance of the electrolytic solution is R2, so cell constant divided by R2. This will give the conductivity of the electrolytic solution present in the conductivity cell. Now, conductivity of different electrolytes in the same solvent. Conductivity of solutions of different electrolytes in the same solvent at a given temperature depend upon the charge of the ions which are formed by the dissociation of the electrolyte, size of the ion which is formed by the dissociation of the electrolyte, concentration of the ions, and the ease with which the ions move under the potential gradient or the mobility of the ions. So these are the factors on which the conductivity depends. Therefore, another quantity known as molar conductivity is introduced, denoted by the symbol lambda m. Molar conductivity is related to conductivity by this equation. Molar conductivity is equal to conductivity divided by concentration of the electrolyte solution. Now, concentration of electrolyte solution can be given in moles per liter or moles per meter cube. Unit of conductivity is per ohm per meter. If concentration of the electrolyte solution is in mole per meter cube, then unit of molar conductivity will be equal to, molar conductivity is equal to conductivity divided by the concentration. Putting the units of conductivity and concentration, conductivity unit is per ohm per meter, concentration unit is mole per meter cube. From this, unit of molar conductivity will be per ohm meter square per mole. This is the unit of molar conductivity. Now, what if the concentration of the electrolyte solution is given in mole per liter and conductivity has unit per ohm per meter? In that case, mole per liter has to be converted into mole per meter cube. So, mole per liter has to be converted into mole per meter cube. Mole per meter cube. How to do this conversion? 1000 liter is equal to 1 meter cube. Then 1 liter is equal to 10 to the power minus 3 meter cube, or 1 by 1000 meter cube. So to convert liter into meter cube, liter has to be divided by 1000. This 1000 goes in the numerator and this becomes 1000 into mole per liter. 1000 is the conversion factor and it can be written as 1000 liter per meter cube multiplied by mole per liter. So liter cancels and the unit of the concentration becomes 1000 mole per meter cube. So in short, if molarity is given in moles per liter, multiply it by 1000 liter per meter cube, multiply it by 1000, which is the conversion factor, and molarity gets converted into mole per meter cube. This will be meter square. This will be per meter. So molar conductivity can be obtained in per ohm meter square per mole by converting molarity in moles per liter to moles per meter cube. Similarly, if conductivity is given in per ohm per centimeter and molarity is given in mole per liter, in that case molarity has to be converted into mole per centimeter cube. Now mole per liter it has to be converted into mole per centimeter cube. 1 liter is equal to 1000 centimeter cube. So mole per liter, liter is converted into centimeter cube. So it can be said that 1 by 1000 into mole per liter will give the concentration in mole per centimeter cube. So here actually mole per liter is getting divided by 1000. Mole per liter is divided by 1000, or molarity is divided by 1000. So in the expression for molar conductance, this is conductivity divided by molarity in moles per liter, and molarity in moles per liter is divided by 1000, which is the conversion factor. That is 1000 centimeter cube per liter. This is the conversion factor. Molarity is divided by the conversion factor, so 1000 goes in the numerator, and this gives the value of molar conductivity in units per ohm centimeter square per mole. Both types of units are used in literature and are related to each other by the equation. The unit in per ohm meter square per mole, if converted into per ohm centimeter square per mole, then 1 meter is equal to 100 centimeter. Therefore, 1 meter square will be equal to 10 to the power 4 centimeter square. So, meter square per ohm meter square per mole is equal to 10 to the power 4 per ohm centimeter square per mole. Similarly, if centimeter square has to be converted into meter square, then 1 per ohm centimeter square per mole is equal to 10 to the power minus 4 per ohm meter square per mole. 1 centimeter square is equal to 10 to the power minus 4 meter square.